Hey guys, in this video we are going to continue our discussion on the discriminant and quadratic formula to make sure that you get plenty of practice with it. All right, so at the top of page 62 in your notebook, we have a little table here about the discriminant once again. So it says you've used the discriminant to find the number of solutions to a quadratic equation, but you can also use the discriminant to determine the number of x-intercepts on the graph of the related function, which is basically the same thing we talked about. Remember that the number of solutions is the same as the number of times that your quadratic graph will touch the x-axis. So if you have a positive discriminant, that means there are two real solutions, which means that the graph touches the x-axis twice. If the discriminant is 0, you have one real solution. So the graph touches the x-axis once. And finally, if you get a negative discriminant, that means there's no real solution, meaning that the graph does not touch the x-axis. So 0 touches on the x-axis. Or if you prefer to put the word none, that might be better. None. No x-intercepts. All right, so let's practice finding the x-intercept, the discriminant. So first, you want to make sure that it's equal to 0, or in this case, equal to y, meaning all of your terms are over on the right side, all of your x terms, which they are. So now we need my a, which is 1, b is 4, and c is 5. Now the discriminant formula is b squared minus 4ac. So I'm going to have 4 squared minus 4 times 1 times 5. And we're just going to let our calculator do the work. So I get negative 4, which means there are no real solutions, or no solutions. So this is the discriminant. This is the number of solutions. All right. We're just going to do the odd ones. So number 3, everything is on the correct side. I don't need to move anything over. So a is 1, b is negative 2, c is 1. All right, so b squared means negative 2 squared minus 4 times 1 times 1. All right. Which is 0. So this is my discriminant. 0 tells me that there is one real solution, or one solution. All right, number 5. Everything that I need on the correct side is already there. So a is 2, b is 11, c is negative 5. Okay, so 11 squared minus 4 times 2 times negative 5. Which is 161. So my discriminant is 161, meaning there are two real solutions. All right, one more. And it's a little bit tricky because you should notice that there are only 2 terms and not 3 this time. So I need to figure out which one's missing. Well, here's the x squared, which means a is 1 because there's no number in front. And there's an x term. That means b is the number in front of that, which is negative 9, which means I have no c, so c is 0. All right, b squared, negative 9 squared, minus 4 times 1 times c, which is 0. So really, this whole thing here is 0, so I'm just left with negative 9 squared, which is 81. So my discriminant is 81. That's positive, so that's 2 real solutions. All right, hopefully you're getting the hang of finding the discriminant. Let's practice some more quadratic formula. All right, so the top of 63, the quadratic formula states that for a quadratic equation in the form ax squared plus bx plus c, where a, b, and c are real numbers and a is not 0, then this formula is true. All right, so solve the following quadratic equations using the quadratic formula. Round your answer to the 100th place, which is 2 decimal places. And always make sure that your equation is in standard form first, and it has to be equal to 0. All right, so it's best to find the discriminant first because it can tell you the number of solutions and which method is best to use here. All right, let's dive into it. It's equal to 0 and in standard form. So A is 2, B is 11, C is -5. So let's do the discriminant. We got 11 squared minus 4 times 2 times -5. And we get 161. Okay, so 161 is positive. That means there are 2 solutions, but it is not a perfect square. So we're going to have to use the quadratic formula. So let's dive into that. B is 11. The opposite of that is -11. So we have -11 plus or minus the square root of 161, because that's where the discriminant goes, over 2 times A, which is 2. All right, so let's find the square root of 161 as a decimal. That's 12.69. So I have -11 plus or minus 12.69 over 4, because 2 times 2 is 4. Now remember that plus or minus allows us to split it up into 2 to get our 2 solutions. So I have -11 plus 12.69 over 4 and -11 minus 12.69 over 4. And then we're going to let the calculator do the work once again. So my first answer is 0.43 or 42. And the second is -5.92. And those are my 2 answers. Number 2. All right, got to subtract the 14 over, get it equal to 0. So I get x squared plus 5x minus 14 equals 0. A is 1, B is 5, C is -14. So now we have 5 squared minus 4 times 1 times -14. And I get 81, which is a perfect square. So I'm going to do this one by factoring. So first I need to find all of the factors of 14. 1 and 14, 2 and 7. 14 is negative, so my signs need to be different. The 5 is positive, so the smaller numbers are negative. And these are the 2 that are going to give me 5 when I add them together. So I get x minus 2 times x plus 7 equals 0. Set them both equal to 0 in order to solve. And I'm going to get x equals 2 and x equals -7. Quick and painless. All right, number 3. Got to add that 9 over first. So 4x squared minus 12x plus 9 equals 0. A is 4, B is -12, C is 9. So we have -12 squared minus 4 times 9. And we get 0, which means that there's only one solution, and once again, we can factor it. So let's find all the factors of 9. We got 1 and 9, 3 and 3. The 9 is positive, so I need the signs to be the same. Middle is negative, and on, oh, sorry, got to multiply 4 times 9. It should be 36, not 9. I'm doing a great job here. Okay. So 4 times 9 is going to be 36. And on second thought, we're going to go ahead and use the quadratic formula. My suggestion to you guys, if A is not equal to 1, I would not factor. You could, and it would be pretty quick, but you'd have to split the middle in order to do it. So I'm going to go ahead and use the quadratic formula. So the opposite of B is going to be 12, plus or minus the square root of 0, because that's the discriminant, all over 2 times A, which is 4. So now I get the square root of 0 is just 0. 12 plus 0 is still 12, and 12 minus 0 is still 12. So really that just kind of goes away. So I'm left with 12 over 2 times 4, which is 8, which is going to simplify to 3 over 2. So my answer is just 3 over 2. All right, number 4. Once again, I got to subtract the 4 over. So I get 4x squared minus 6x minus 4 equals 0. A is 4, B is negative 6, C is negative 4. So I'm going to do negative 6 squared minus 4 times 4 times negative 4. I get 100. All right, so this is positive, meaning there's going to be 2 solutions. It's also perfect square, meaning you could factor it, but A is not 1, so I'm still going to use the quadratic formula. So the opposite of B is 6 plus or minus the square root of 100 over 2 times 4. The square root of 100 is 10, so I get 6 plus or minus 10 over 8. So I get 6 plus 10 over 8 and 6 minus 10 over 8. So 16 over 8 is going to be 2. And then negative 4 over 8 is negative 1/2. So those are my 2 solutions. All right, couple more. This one's already equal to 0, so A is going to be 1, B is negative 8, C is negative 11. So let's find the discriminant. Negative 8 squared minus 4 times 1 times negative 11. And that is 108, which is positive, meaning there are 2 solutions, but it is not a perfect square, so we definitely have to use the quadratic formula for this one. So the opposite of B is positive 8, plus or minus the square root of 108, all over 2 times 1. The square root of 108 is approximately 10.39. So I have 8 plus or minus 10.39 over 2. So 8 plus 10.39 over 2 and 8 minus 10.39 over 2. So the first answer we get is 9.2. And the second is negative 1.2. All right, last one. We got to add the 19x squared over. And make sure it's in standard form. So 19x squared minus 10x plus 1 equals 0. That means A is 19, B is negative 10, and C is 1. Okay, so we have negative 10 squared minus 4 times 19 times 1, which is 24. Once again, positive, so there's 2 solutions, but it is not a perfect square, so we're going to have to use the quadratic formula. So the opposite of B is 10. So 10 plus or minus the square root of 24 all over 2 times 19. The square root of 24 is 4.9. So we have 10 plus or minus 4.9 over 19 times 2, which is 38. So we're going to have 10 plus 4.9 over 38 and 10 minus 4.9 over 38. So that's 0.39. And 0.13. And that's it, guys. That's extra practice with the discriminant and the quadratic formula.